Alright, so just more trig derivatives. So far all we know is that the derivative of sine is cosine and that the derivative of cosine is negative sine. Now we're going to have 4 more to add to our plate. The derivative of tangent is secant squared, and the derivative of secant is secant tan. Derivative of cotangent is negative cosecant squared, and the derivative of cosecant is negative cosecant cotangent. 4 more that you have to memorize, and we'll work with them more, especially now that we know our product and quotient rule. And actually, as I look at this first one, in this section, we're definitely going to need the product rule because we have 2 functions really being multiplied. So y prime will equal, and just for this portion first, I have the first times the derivative of the second, derivative of sine is cosine, plus the second, which is sine x, times the derivative of the first is 1. So there's the derivative of this, plus the derivative of cosine is negative sine. So we'll just simplify this out. We have x cosine x plus sine x minus sine x, and nicely enough those cancel. So your derivative ends up just being x cosine x. Okay. Your derivative of sine x over x, classic quotient rule, so bottom times the derivative of the top minus your top times the derivative of the bottom, all over bottom squared. Clean it up, and you're done. There's your derivative. Next one, we get into one of the new functions. So our derivative of this, starting with the first term of the polynomial, derivative of x is 1, plus our derivative of cotangent. If we look back up to the top, our derivative of cotangent is negative cosecant squared. And so we just clean this up. And we're done. And then here we're going to have to do the product rule because we have the first and the second. And then we're going to have to do the product rule again, first times the second. So this one's a little bit trickier, or just longer really, but you got to stay organized, and that's the tricky part. So h prime of theta. So we have our first times the derivative of our second. The derivative of secant, if you look up at the top, is secant tan. Not x's, we're dealing with theta, so secant theta, tan theta. First times the derivative of the second, plus the second, times the derivative of 5 theta is just 5, plus, I'm going to get into the product rule here. First times the derivative of tangent, which if you look up top is secant squared, plus the second times the derivative of just theta is just 1. Because theta is like an x here, so your variable. So when I clean that up, oh boy, I'm going to get 5 theta secant theta tan theta plus 5 secant theta plus theta secant squared plus tan theta. The only thing I could think of that you might do to simplify this would be, there is no combining like terms. Maybe here we could do a 1 over cosine and a sine over cosine and multiply those and have a denominator of cosine squared. But, you know, I'm not just going to start doing stuff. If I just needed the derivative and it was open response, I'm good with this. But if it is a multiple choice, or if you're checking your answer in the back of the book, if it's something different, see kind of how this would manipulate into that, if you have to do more. Maybe a 1 over cosine here, but then you'd have to get kind of common denominators. This would be 1 over cosine squared, and this would be sine over cosine. So really all would have denominators of cosine or cosine squared, so getting a common denominator wouldn't be that ugly. But again, I'll leave you to do what you need to do depending on multiple choice answers or the answers in the back of the book. Alright, now just same type, evaluating the derivative. So for this derivative, we're going to evaluate it at an x value of 1, but we have to find the derivative first, which is going to take the product rule. So we have the first times the derivative of the second, and if you look on the back, the derivative of the second is negative cosecant squared x. So first times the derivative of the second plus the second times the derivative of tangent. Again, that's one of our newer ones. Derivative of tangent secant squared. And then just clean up. So this is negative tan x cosecant squared x plus cotangent x secant squared x. Okay? And then we want to evaluate this at 1, which would 100% require a calculator, because we don't know the tangent at 1. F of 1 would equal, and I will, let's see, it's not 1 degree, so I'm going to assume it's 1 radian, so make sure my mode is in radians. So negative the tangent of 1 times, I can't do cosecant squared, but I can do 1 divided by the sine of 1. I'm going to do the sine of 1 squared, so 1 over sine squared. Close that. And then I'm going to add the rest. Again, I can't do cotangent, but I can do 1 over the tangent of 1 times 1 over the cosine squared of 1. And 0. All of that, we get that the derivative at 1 is 0. Now that would be interesting to look at and check. So let me take a peek at the graph of this, just to confirm that we do have a slope of 0 at that point, which means at 1, 1, it should be a relative max or a relative min. If I type in the tangent of x times, oh, of course, 1 over the tangent of x. Seems obvious now, because if I go from 0 to 2, 1 should be right in the middle. Right. The whole thing has a slope of 0 because it's a horizontal line. And again, I overlooked that at the beginning, but if I do look now, of course, tangent of x times 1 over the tangent of x would just be the same as the line y equals 1. Of course, ours has a few holes in it. We do have a few holes in ours because there are a few undefines. We don't see them, but we should know that they're there. But all in all, it should look like the line y equals 1, and it does, and the slope is 0, so that ends up making complete sense.